Welcome back to my channel FFVMD. Franklin Faraday FFB B Maxwell Brewsters and Dr. Tesla. And uh, we have gone through the problems of KVL and KCL. Using KVL and KCL, we have solved many problems. Again, we will see some another problems, and we will solve this using Kirchhoff's voltage rule and Kirchhoff's current rule. So let us start. Find VA minus VB in the circuit. Here circuit is shown. This is circuit 1 and this is circuit. This is a loop. Here and this is a loop. That is closed circuit. Both are closed circuit, and we have to find potential difference between A and B point. So let's solve first problem. Here it is shown. The current distribution is shown here. For example, we have considered that I1 current is flowing through this cell, and at this point, and again I2 current is flowing this cell, and at this point both meets, and I1 plus I2 current is flowing in this. Now again at this point, this will be divided into two part. I2 will be go in this direction and I1 will be go in this direction. So current distribution is shown, and this is a cell of EMF E1 and this is a cell of EMF E2. This is R1, R2 and R3. Resistance are given. So we can apply KVL. We have to select the loop and then we have to apply the KVL, Kirchhoff voltage rule. So here KVL in loop A, B, B, A. A, B, B, A, A. This is the loop where I am going to consider about the Kirchhoff voltage rule. So going in this direction as written in the here. So we are going from A to B, B to B, B to A and A to A, so that our loop should be complete. Now this is we are final is lower and initial is higher. That is negative plate. We know that negative plate of cell is always at lower potential, and positive plate of cell is always at higher potential. So minus of E1. Now here current is flowing in this direction. That means that this point is at higher potential and this point is at lower potential. So higher minus lower, so voltage about this will be positive. So plus I2 into R2, because I2 current is flowing here, is shown it is I2. So I2 into R1 plus again we go in this circuit, in this line I1 plus I2 current is flowing. Now we are going from here to here. So from this is at higher potential, this is at lower potential, so it will be again positive. So I1 plus I2 into R3 equals to 0. Now because now we have completed this loop. After going through, there is no another component, electrical component in the loop, so finally we have got equal to 0. This implies I2 into R1. This implies I2 into R1 plus I1 into R3 plus I2 into R3 equals to E1, taking this side, so E1. Or this implies I1 into R3 plus I2 into R1 plus R3 equal to E1. This is equation 1. Again apply KVL in loop A, B, C, D, A. Our loop is here A, B, C, D, A, and going in the same direction as we have talked about the loop. So I am going in this loop. I1 plus I2 is flowing in this line. So and we are going from higher to lower. So lower minus higher will be negative. So minus of I1 plus I2 into R3, minus of I1 plus I2 into R3. again we are going from higher to lower, that is lower minus higher will be negative. The minus of and in this loop I1 current is flowing in this line, so minus of I1 into R2, minus of I1 into R2, and here we are going in this direction, so this is higher and this is lower, so higher minus lower will be positive, so E2 plus E2 plus E2 equal to 0. So this implies I1 plus I2 into R3 plus I1 I1 into R2 equal to E2, or this implies I1 into R2 R3 plus I1 this R3, so I1 taking common R3 plus R2, and I2 into R3 equals to E2. Now from the equation 1 multiplying R3 plus R2 minus of equation 2 multiplied by R3, we get the flowing value. Here equation 1 is multiplied by R3 plus R2 and then it is subtracted and minus equation 2 multiplied by R3. From this we get equation 1 is multiplied by I1, so it will be I1 R3 into R2 plus R3 plus I2 into R1 plus R3 into R3 plus R2, a minus of I1 into R3 plus R2 into R3 minus I2 into R3 square equals to E1 into R3 plus R2 minus E2 into R3. So this will cancel out. Now we are left with I2 into R1 plus R3 into R3 plus R2 minus of R3 square equals to E1 into R2 plus R3 minus E2 into R3. This is a complicated mathematics, but we can solve it by simple rules of mathematics. So we have again simplifying it, I2 under bracket R1 into R3 plus R1 into R2 plus R3 square plus R2 into R3 minus of R3 square equals to E1 into R2 plus R3 minus E2 into R3. Now this will cancel out, so we have I2 equals to E1 into R2 plus R3 minus E2 into R3 divided by R1 into R2 plus R2 into R3 plus R3 into R1. So we have get the value of I2 in terms of EMF and resistance in formula form. Now we have to calculate the value of I1. So again, now from 1 we have I1 into R3 plus R2 equal to E2 minus I2 into R3. So we can write I1 equal to E2 by R2 plus R3 minus I2 into R3 by R2 plus R3. Now we should put the value of I2 and solve it, and we will get the value of I1. So here E2 by R2 plus R3 minus R3 by R2 plus R3 and value of I2, that is E1 into R2 plus R3 minus E2 into R3 divided by R1 R2 R3 plus R3 R1, and now we have to solve it. So we have the value of I1 in the formula form again, because there is no all resistance E1 and E2 are given, so we can find the value directly using its numerical value. Now if we take I1 plus I2, then we have to E2 by R2 plus R3 minus R3 by R2 plus R3 into E1 R2 plus R3 minus of E2 R3 divided by R1 R2 plus R2 R3 plus R3 R1, and plus value of I2 E1 into R2 plus R3 minus of E3 into E2 into R3 divided by R1 into R2 plus R2 into R3 plus R3 into R1. We are simplifying it. Now we can write this will be equal to E2 by R2 plus R3 a minus of from it we have taken or equals to R3 by R2 plus R3 minus 1 into E1 into R2 plus R3 minus E2 into R3 y divided by R1 R2 plus R2 R3. This value had taken common from here and plus R2 into R3 plus R3 into R1. Now E2 by R2 plus R3 equals to, under solving it, R3 minus R3 divided by R2 plus R3. This will cancel, and into E1 into R2 plus R3 minus E2 into R3 divided by R1 R2. Again we have E2 by R2 plus R3 plus R2 divided by R2 plus R3 under bracket E1 into R2 plus R3 minus E2 into R3 divided by R1 R2 R3 plus R3 R4. Hence now we have VA minus VB. We have to find the potential difference, so we can write VA minus VB equal to I1 plus I2 into R3, because we know that V is equal to IR. So here current in that line is I1 plus I2 and resistance given R3, so we have to put this value. So will be equal to R2 into E2 R3 E2 by R2 plus R3 plus R2 into R3 by R2 plus R3 into under bracket E1 into R2 plus R3 minus E2 into R3 divided by R1 R2 plus R2 R3 plus R3 R4. And solving it, we have R3 into E2 by R2 plus R3 plus R2 R3 by R2 plus R3 into this part, the E1 into R2 plus R3 divided by R1 R2 plus R2 R3 plus R2 R3 R1, and minus of E2 into R2 into R3 square and R2 plus R3 into R1 R2 plus R2 R3 plus R3 R1, and this will cancel out, and taking this value R2 E2 here, from this and from this take it common, so R2 into E3 by R2 plus R3 we have 1 minus R2 R3 by R1 R2 plus R2 R3 plus R3 R1, and plus we are left with this R2 R3 E1 by R1 R2 plus R2 R3 plus R3 R1 equals to R3 into E2 by R2 plus R3 into, now solving it, this will be R1 R2 plus R2 R3 plus R3 R1 minus of R2 R3 divided by R1 R2 plus R2 R3 plus R3 R1 plus R2 R3 E1 by this value. So this will cancel, this equals this, and this has cancelled. Now this is R1 R2 and this is now R1 R3 E2 by R1 plus R2 plus R2 R3 plus R3 R1 plus if we take R1 common, then it will be R2 plus R3, which will be cancel out. So we have taken R1 R3 into E2 by R1 plus R2 R2 into R3 plus R3 R1, and plus this value R2 into R3 E1 by R1 plus R2 plus R2 plus R3 plus R3. So finally taking LCM, we have R1 R2 plus R2 R3 and R3 R1 and equals to R1 R3 into E2 plus R2 R3 into E1, or this can be also written as equal to E1 by E2 by R2 dividing R1 R2 R3 on both side, upper side and lower side. So this will be E2 by R2 plus this will be E1 by R1, and this will be 1 by R3 plus 1 by R1 plus 1 by R2, or E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2 plus 1 by R3. Now the second circuit is same as one. If we see very closely, then we find that the circuit is same, only their diagram has changed. For example, here we see that here for this in point A and B R3 is connected. Again we see here in A and B, point A and B, there is a R3 in point A and B between, and one end of E2 is connected to A, one end of E2 is connected to A, and other end with R2, other end with R2, and again R2 is connected to B, so again R2 is connected to B. Again if we see in this positive plate is connected to A, so here positive plate is connected to A, and negative plate is connected to B, negative plate is connected to B, and there is a resistance R1. There is a resistance may be in this side or this side, this does not matter. You can put this resistance in this side or this side. This should be in the same line. So both figure are same, so answer will be same as we have calculated in one using Kirchhoff's law. Now our next problem is find the current through the 10 ohm resistor shown in the figure. It is a figure, it is a closed circuit shown, and we have to find the current in this resistor. What current is flowing? And we will solve this problem with using the Kirchhoff's voltage rule and Kirchhoff's current rule. We take one current flowing, and first we decide first we assign a current in the circuit, and then we solve it. For example, the current distribution here is on, that is we are considering the I current is flowing along this line, and again it flowing at this, and this point it divided into two parts. I1 is going in this circuit and I2 is going again at this point it becomes I, that is add up to I. So our current distribution is right here. Now we can write I equal to I1 plus I2 at point A or at point D, and KVL in loop ABCD, applying KVL, Kirchhoff's voltage rule in ABCD in this loop ABCD. So let us start from here. So we are going in this direction, we are going higher to lower, so this will be negative, so minus 10 I1, and I1 current is flowing. Again going this as this is lower and this is higher, so minus E minus 3 plus in this we are going from lower to higher, this is higher and this is lower, so it will be positive, so I2 into 6, so 6 I2 equal to 0, or this implies 6 I2 minus 10 I1, 6 I2 minus 10 I1, and this will be here in this equation 1. Again applying KVL in ADEFGA, our circuit becomes closed. So moving in same direction here, as we have taken the loop, here we are going from A to D, and it is at higher, it is at lower, so minus 6 I2, here will be minus 6 I2 again in this. Now here in this line is current I, it is should be kept, and here from lower to higher, so higher minus lower will be positive, so 4 plus 4.5 plus 4.5 volt, and again in this there is no current, and here it is a current. Again we are going from higher to lower, so will be negative, so minus I into 3, minus 3I equal to 0, or minus 6 I2 plus 4.5 or minus 3 into, because I is equal to I1 plus I2 we have calculated earlier in equation 1 it is. So using this value minus 3 I1 plus I2 equal to 0, or this implies 6 I2 plus 3 I1 and plus 3 I2 equal to 4.5, and this implies 3 I2 and 6 I2, 9 I2 plus 3 I1 equal to 4.5. This implies 3 I2 plus I1 equal to 1.5. So now using this relation, equation 1 minus 2 into equation 2 gives 6i2 minus 10i1 minus 6i2 minus 2i1 equals to 3 minus 3 equal to 0. This imply minus 12i1 equal to 0. This imply i1 equal to 0. Answer. And from 2 i2 equal to 1.3 by 3. From equation 2 i2, from equation 2 we can get, because i1 is 0, so i2 will be 1.5 by 3. 1.5 by 3 equal to 0.5 ampere. So we have calculated this value using Kirchhoff's voltage rule.